Welcome Math 10. We are doing section 8.2. This is on page 305. So we are skipping 8.1. I know you're going to be sad about that, but this will keep you happy. This is the distance formula, and everybody in the whole world knows this formula. This comes from Pythagorean, and they're going to lead you through and show you how this happens. So they say, consider line segment AB shown in the grid. Use Pythagorean theorem to show that the length of AB is 15 units. So to use Pythagorean, you know you have to have a right triangle. So we are going to draw a right triangle attached to the endpoints of our line. Then we will count the units on the bottom, and we will find that we have 12 units of distance along the bottom. Count the units up the side, and we'll find 1, 2, 3, 4, 5, 6, 7, 8, 9 units up the side. Now we can use Pythagorean theorem. C squared equals A squared plus B squared to find the distance of AB. So substitute AB squared equals A squared, which we know A is going to be 12 squared plus B is going to be 9 squared. Remember, the order of those doesn't matter, A and B or B and A. Either way, in we go. AB squared equals, and you can do that on your calculator, and that'll be 225. Square root, square root. When you square root a squared, you get plus and minus, but because this is a distance, it will be positive, and you will just write the positive value. So AB is equal to 15, which is what they wanted us to know. So some smart guy, Pythagoras, rearranged his own formula, and then we can find the distance without plugging into the Pythagorean theorem directly and then rearranging. He's rearranged already. So if we just use this space in your book, he has rearranged, and distance is going to equal square root of x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared, where x1, y1, x2, y2 are the points. So A is at -5 and 3, -3 from above, and B is 7 and 6. So if I let this be point 1, this is going to be x1, y1. If this is point 2, x2, y2. And now I just have to be careful that I am putting them in the right positions. So in we go. Square root of bracket x2, so 7, take away a -5, end of bracket squared, plus bracket y2 is 6, take away a -3, end of bracket squared, and 12 squared plus 9 squared equals square root of 225, which equals 15, which is what we wanted to show. The distance formula given on the next page is exactly what we already wrote on the previous page, and the formula you can highlight right there. Let's use that in example 1, and we will find the exact length of the following line segments. So first, this is going to be our x1, y1, x2, y2, rewrite the formula. So D equals square root of x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared equals, and now we'll substitute. So 10 minus 2 in brackets squared plus -3 minus 3 in brackets squared equals square root of 8 squared plus a -6 squared So square root of 64 and 36 is 100, which equals 10 units. Isn't that a wonderful formula? Okay, that's what we're doing. So questions 1, 2, just do B, then 5 through 7, 10, and 12.